What up, guys? Here we go. We're doing our practice problems at segment addition postulate. So let's just hop right into this. So it says find the length indicated. So the indicated length is this question mark here, and the whole concept behind the segment addition postulate is that this one plus this one equals this one. So if we were just going to go ahead and write it in like the fanciest of terms, I'm going to do super fancy the first time. I will not do it super fancy in the future. So you have a TS. Remember, we don't put those that arrow on top because or the line on top because we're talking about a length. So TS plus SR is equal to TR. So that's like the segment addition postulate says. That's the fanciest way of writing it. But the way we're going to do it is 4 plus this question mark that we don't know is equal to 11. I think it's nice and easy on this one. We don't really need to think about it too much. 4 plus what number is 11? If you really needed to show it, we could do something fancy like a -4 on both sides here, just to be a little obnoxious with it and, do some canceling on it. But I don't think that's really needed because 11 minus 4 is a nice and easy 7. So what I'm talking about is you didn't necessarily need to show all of that stuff. I would have been completely and totally fine if you just said, well, I know that all I have to do on this question is 18 minus 6 and get you 12. Likewise, this question itself would have been completely and totally okay if you had just answered 12, for instance. You didn't even write that 18 minus 6, but writing the 18 minus 6 gives you the chance of getting the question right if you made a small mistake, such as if you did 18 minus 6 and you by mistake got 11. Happens to me all the time. You make mistakes like this. Not a big deal, but if you don't show any work, I can't give you credit for it. So you got to make sure you're showing some of that work. Let's go on to the next one here. So this one, we have to draw it ourselves first. So A, B, and C are collinear, and point B is between A and C. So it's like in that correct order. Let's go ahead and write that out. Let's do here, here, and here. We have an A, we have a B, we have a C. They're all in that correct order there. And now you're told that this length here is 10, and that this entire, so because it says BC is 10, and then this entire length here is 16, and it's asking you to figure out what is that question mark right there. So just like before, I think it's nice and easy. We could just do a nice 16 minus 10. I almost circled that. That's too funny. Is equal to 6 for our final answer there. There you go. Didn't mean to circle the other part of that. Anyways, let's keep the show moving here. We're going to do exactly the same thing. We're going to draw another A, B, and C. And again, if you're able to do any of these in your head, you are allowed to. You do not need to draw all these pictures. I just do every single time just to make sure I'm getting the question right. AB is 10. AC is 11. And because of that, that's definitely got to be a 1. So you do 11 minus 10 if you wanted to show the work for it. Every single one of these, if you wanted to, you could have also said something like here on this one, you could have said like BC equals 1. I don't think that's needed. Let's move on to the next one. Number 5. So the reason why number 5 is a little bit tougher is because we have all these different parts and we got to figure out, which one is this, how long is this one. So really what I would notice is because this length here is 9 and the entire thing all the way across is 11, this part right there must be equal to 11 minus 9, which is equal to 2. So that part right there is equal to 2. And you can use exactly similar logic because this part here is also 9, that this right here is also 11 minus 9 is equal to 2. Finally, if the entire length is 11, and we're subtracting both of those little endpoints, both of those 2's, our final correct answer is 7. I do think over here, number 6 is a lot easier, mainly because you're simply going to go ahead and do a little bit of subtraction. So we're going to have 16 minus 8 minus 3, that entire length, and you're subtracting the other 2. And if you did 16 minus 8 minus 3, you do in fact get 5. Let's keep the ball rolling. Here we go, number 7. This one, you absolutely got to draw pictures on all questions like this, in my opinion. Very difficult to do a question like this in your head, but if you're able to do it in your head, more power to you. Probably could have done it in my head before I got COVID, but I'm just talking to the wind right now to keep myself occupied. Hope your day's going all right. There it is. A, B, C, D. So we have AD is 23, so that's the entire length of the whole line is 23. Then we have AC is 12, so I'm going to do this one above. So this part here is 12. And that means that we're told that BC is 4, and we need to find BD. So it wants us to find this length here, question mark. So what you can do is just break this into multiple parts. We're clearly going to need to figure out how long CD is, but the only thing we have information about letter CD is this whole length of 23. And what's left over from that, we can use the 12 to figure out that this one, I'm going to use a different color so it's more clear what I'm doing here. This one right here, because that's like all set up, right? All the blue isn't set up. I'm using my purple to talk about that one right there. That part is going to be 23 minus 12. You're taking the whole, sorry, not 23 minus 12. Wrong about that. You're taking the whole 12, A to C, and you're subtracting away that 4. So it's going to be a 12 minus 4, which is equal to 8. So we can go ahead and put a little 8 on top of that. And if the entire length is 23, we can just do 23 to figure out what this length is here anyways, right there. That one's got to be 23. I wrote a 1. Yikes, Mr. Richards. 23. And then subtracting away. What am I even doing? I got sidetracked with myself trying to figure out this length. So 23 minus the 12, right? That's all we have to do is just minus the 12. Yeah. That's going to give you 11. We didn't even need to figure out that 8, did we? That was a total waste of time. Sorry, guys, you wrote down useless information over here at this 8. That's what happens when you're doing math problems. Sometimes you do a little bit of extra work, and if you do that in like a middle of an SAT or ACT or something, you end up wasting time. So you got to be practicing and careful. Clearly not being careful enough here. Regardless, you need to find BD. I think it is nice and simple that we can just go ahead and say that BD is equal to 4 plus that 11. And that's going to give you 15 for our final answer. Let's move on to the next one. Do exactly the same thing. We're going to draw the picture and do all the stuff we can. Maybe not exactly the same thing because hopefully we don't do that screw up where we use information we didn't even need. Yeah, this is the part where, like, if I had a video editor, I would just tell him all these parts where I just talk nonsense and just talk to myself. You just speed the video up really fast because I'm drawing, whatever. All right, BD is 8, so that's this length here is 8. The entire length all the way across is 17. BC, just that little tiny part, is 6. And it needs us to find AC. So we're really going to need to figure out what this one is right there. To figure out what that one is, what will we do? I think we're just going to do 17 minus 8. Because if you do 17 minus 8, you'll get, yep, that's all you have to do there. So you can go ahead and say that this one right here, that question mark, is 17 minus 8. And that's going to give you 9. And AC is going to have to be the 9 plus the 6. And that's also going to be 15. Both those guys have the same answer of 15. Very cool. Let's move on to the next problem. So now, for me, this is on the back. I don't remember if I printed it if yours double-sided. I probably did. But here we go. Solve for x. So in order to solve for x, we're using that same exact segment addition postulate, but now we have to do a little bit of algebra. If your algebra is not that strong, that's okay. We're going to practice it right now. So we have the 3x minus 2 plus, so we have that length here, plus the negative 7 plus 2x is equal to 11. And now we have to solve this algebra. If you were in class, you probably saw me do this question quite fast, but because I'm doing it in the video, I want to make sure that everyone is well aware of the different steps that you could take to solve these algebra questions without really struggling. So I'm going to go ahead and do kind of like old school stuff. Your teachers might have done this a long time ago, where you go through and you put like an underline with every single thing that has an X on it. We call those like terms. And we're going to go ahead and combine those. So we're like going to take this one, and 3 plus 2 is equal to 5. Likewise, you could do something slightly different. Maybe we're going to go ahead and like circle. How about we circle the ones that have a no, that do not have an X on it? So -2 minus 7, -2 plus -7, or -2 minus 7, regardless of the way you say it, those two are going to become -9. And then the right-hand side stays the same. From here on out, we can solve it just like a regular old equation. So we're going to go ahead and add 9 to both sides here. (11 plus 9 is 20. Last but not least, we're going to divide both sides by 5. So we divide by 5, divide by 5, and in fact, x is equal to 4. You have to be careful. It did say to solve for x, and we did solve for x. We're good to go. Let's do question number 10. So in question number 10, it's the same exact concept. We're going to have that x. We're going to add 4 to it. That's going to give you 2x minus 7. I want to make sure I don't go off the page. Let's scroll this over here. 2x minus 7. So we had the x plus the 4 is equal to 2x minus 7. This is going to be the very first question on my video anyways that has what I would call the switcheroo. The switcheroo is when we divide the question into two different parts, and we're going to move all the x's to one side and all the not x's to the other. So kind of just like I did before, I'm going to go ahead and underline every single thing that has an x here. And I'm going to go ahead and circle all the things that do not have an x. And all of the things that have an x, I'm going to go ahead and move off to one side. All the things that do not have an x, I'll move to the other. Because the x is bigger on the side with the 2, I'm going to choose to move these ones to the right. So we're going to go ahead, we're going to rewrite this equal sign. That 2x is going to stay in the same exact spot. But that x, anytime you move something from one side to the other, it changes sign. So you're going to move x to the other side, and it's going to change sign to become a negative x. The 4 is going to stay in the same exact spot, but the -7 is going to move to this side and become a positive 7. Finally, 7 plus 4 is 11. 2x minus x is just x. If you were confused as to why, there's two ways to think about it. I like to think about it anytime I see an x, I just replace it with the word apple in my brain. 2 apples minus an apple is 1 apple. You could also put an invisible little 1 in front if that makes you happier instead. So you put that 1 in front right there, then yeah, you'd be good to go. All right, I'm going to move on, circle it, and continue moving on to question number 11, where it says find the length indicated. This time is going to be exactly the same as questions numbers 9 and 10, but you'll have one extra step at the end where you need to go ahead and like figure out what this guy is here, this KL. So let's do that. So we're going to do x minus 1 plus 2x minus 19. You see everything on the screen? Yep. Is equal to 13. So because on the previous one up here, I already did all the underlining and all that stuff, I'm not going to do the underlining this time. I'm just going to go ahead and combine like terms right away. The x plus 2x is 3x. And the -1 minus 19 is -20. We're going to add 20 to both sides of the equation. But this time I didn't show it. because that is something I want you to get used to. You don't necessarily need to show every single little tiny step of work, and it's actually better for you if you don't, because you're going to save yourself time and effort and energy. I was just mentioning those SATs and ACTs earlier. The faster you work, the more time you have to think, the more time you have to check your work. So by not writing that little plus 20 on both sides, I've saved myself just a little bit of time, but maybe I've saved myself 2 seconds. But if I save myself 2 seconds across 30 problems, now I've saved myself an entire minute, and an entire minute could be the difference between getting a good score and not a good score. Anyways, I'm going to go ahead and divide both sides by 3 now, and I get x is equal to 11, but be very, very careful because KL was equal to x minus 1, and it wants us to find KL. We just figured out that x is 11, so KL is 11 minus 1, which is 10. That's our final answer. Let's continue on. We're finding SR. This one's going to be 2x minus 21 plus that 6 is the entire length, x minus 4. Just like that previous one I did up here where I did that switcheroo and tried to explain it, on that one would be the same thing, but I'm just going to start doing it. The 2x is copied. We're going to move that to the left. This x is going to move to the left as well, and that x is going to become a minus x on the right-hand side. And if you notice that negative 21 and the positive 6, I did not write down because I'm moving them over. So that 21 is going to become a positive 21. That 6 is going to become a negative 6. And that negative 4 gets canceled. Or not canceled, it gets copied, sorry. 2x minus x, that's just x. We already had a question just like that. And then 21 minus, it's like minus 10, is 11. Last but not least, it wants us to find SR. So SR was equal to 2x minus 21, which is 2 times 11 minus 21. 22 minus 21 is 1. Let's keep it moving. Number 13. So A, B, and C are collinear. B is in between. So this is yet again a one that you could draw. But I've been trying to get people to do things in their head. If this is one that you could do in your head, I'm going to explain how you could. AC must be the entire length because B is in between. So this is like the entire thing that's going to be on the right-hand side that we've been doing, just like I did my 13 on the right there, or the x minus 4 on the right over here. That 2x minus 3 is going to end up on that right-hand side. So I'm going to do that in advance. 2x minus 3. And then likewise, the AB and the x minus 3 are going to be added together. So it's going to be 9 plus x minus 3. So that's going to be doing the setup before I even drew the picture. But like I said, we always draw the picture out every single time. But if you're somebody who does not need to do that, then don't. And more power to you. Anyway, so AB, this guy is 9. BC, that's x minus 3. And AC, the entire length from side to side there is the 2x minus 3. And that's how we got what we got. We're going to go ahead and do that switcheroo one more time. Just like last time, the number 2 is bigger on that side. So we're going to go ahead and copy that down and start from there. We're going to move that x to the other side to become minus x. A really great trick to learn early on in your math career is that if you have something that's exactly the same on both sides of the equation, that's like this, where you have a subtracting 3 and a subtracting 3, you can just cancel them out completely. They're not even there. You can just go ahead and say, you know what, cancel them, they're gone. You might have been used to doing things like plus 3 on both sides maybe, but if I did plus 3 on both sides, I get 0. Then after that, there's only the 9 left. So 9 is, in fact, our answer. 9 is equal to x. Same exact thing here, where I said we're going to draw that picture. But again, if you didn't want to draw the picture, AC is that entire length. So we can just set this up early and say, hey, that whole thing is equal to 19. And we are adding up 2x minus 2 plus 2x minus 3. Those two things added together are going to be the entire length. But let's draw that picture. Let's show that we really know what we're talking about here. AC, again, is that whole length from side to side is 19. The BC is 2x minus 2, and the AB, 2x minus 3. Regardless, we have a 2x, and a 2x is a 4x. And the negative 2 minus 3, we're moving those to the right-hand side. We're going to show as little work as possible on this one. The minus 2 and the minus 3 move to the right-hand side. It'll be a plus 2 and a plus 3. Adding 2 and adding 3 is just like adding 5. 19 plus 5 is 24. Divide both sides by 4. Get a nice, beautiful 6 as our answer. And again, if you ever need me to show more work, you just got to tell me, hey, Mr. Richards, I'll show more work on that one. Ask me for help in class, no big deal. Let's do it. We're moving on to question number 15 now. It's question number 15, all the way back at the top. Same exact concept as we were just doing, but this time it wants us to find the whole AB. Just like before, I was saying you can draw that picture if it's helpful to you, but this one, let's try to do it without the picture. So we're going to do this with no picture. AC is the entire length, so we know that one's on the right-hand side. That's our 13 there. And then our AB is x plus 8, and we're adding that to x plus 19. The x and the x added together is going to give us 2x. And then just like the last one, we're going to do our subtraction. Now, let's say we had a calculator with us, because we do here. So I'm just going to go ahead and show you my calculator really fast. Hopefully it doesn't die on me. I was just charging it. So if I did this on the calculator, what I could do is I could do like 13, and I know I'm taking the 8 and moving it over, the 19 and moving it over. They're both going to get subtracted. So if I just did minus 8, minus 19, and I did it on my calculator, this is a way you could show less work while still not necessarily doing it in your head and using that calculator instead. So we got that minus 14. Now we're going to divide both sides by 2. And just to show you, you could just divide it by 2 in your calculator. See how I did that, where I just did divide by 2 and it says these letters A and S? What it's doing is taking the previous thing that I had and dividing that by 2. It's going to give us negative 7. Real nice. Let's do it again. Again, no work needs to be shown, but if you want to draw that picture for yourself, you absolutely can. There's never anything wrong with that. So we're going to go ahead and, oh, I'm not done. I just lost points. Mr. Richards, it says find AB if x is negative 7. So AB is equal to x plus 8. But we just found out that that's negative 7 plus 8. That's 1. Almost missed that one, guys. It's not what I'm supposed to circle there. Final answer here. Maybe I should box it. There you go. Box and circle. That's the right one. All right. Same thing over here. AC is that whole length. It's 12. And AB is going to be x minus 8. And BC is going to be x minus 2. Maybe I should put a little plus sign in between because we're adding them. That's the segment addition postulate. An x and an x added together is a 2x. Just like I was saying before, when I take a negative 8 and a negative 2 and move it to the other side, it becomes a positive 8 and a positive 2. Adding 8 and adding 2 is just like adding 10. 12 plus 10 is 22. Divide both sides by 2, you get 11. BC is x minus 2. BC is 11 minus 2, which is 9. Let's keep on moving. Number 17, same exact idea. We're going to keep on going, maybe even faster and faster. Who knows? Let's go. 4 plus x minus 1 plus 7 is equal to the whole length, 3x plus 2. We have another switcheroo. Just because people might be in the struggle bus right now and they want to see a longer version of it. Maybe I will. Let's see what my longest version is. We're gonna do the longest version possible of this, right? I draw my entire line down the center. There's me dividing the problem in half. I'm gonna copy down the 3x because 3 is the biggest x value. We're gonna keep it with the biggest one over there. And that also means I'm going to copy down this positive 7, copy down this negative 1, copy down this 4. But that means that this positive x needs to be moved over here to become a negative x. And that 2 needs to move to the left to become a negative 2. And then we're going to use our calculator. So again, I don't necessarily need a calculator myself for these one-digit numbers, but maybe you do. That's not a problem. You just type it in exactly as it appears. You type it in 4 minus 2 minus 1 plus 7. You hit enter. It's going to give you that right answer. So you don't really have to do these in your head like I'm doing them. 3 apples minus 1 apple is 2 apples. Again, that's how I'm thinking about it in my head. I'm dividing both sides by 2 now. And again, I'm trying to show that maximum work. So we're actually going to show that divided by 2. Final answer. It does say solve for x, so I'm done. Beautiful. 4 is equal to x. Number 18 now. So number 18, same exact idea. 7 plus 2x plus 2x plus 3 plus 11 is equal to 21. Showing much less work on this one now. So let's do this one in the fast way. So this one as slow as possible. Over here, fast as possible. 2 plus 2 is 4. And then I'm doing 21 and subtracting this 11, this 3, and this 7. 21 minus 11 is 10. Minus 3 more. Something weird happened on this one. What did I do? 21 minus 10. Minus 3 more is 7. Right? 21 minus, sorry, 10 minus 7. Is that 0? What am I doing? Do I get 0? Is it actually 0 is our final answer? If I plug in 0 or 7 plus, yeah, it is. You're allowed to do that. It's allowed to be 0. I got confused with myself because I'm not expecting it to be 0, but this is a great chance to be aware of the fact that x isn't in fact equal to 0. There are 2 ways to think about this question. Number 1, you could realize that you're asking yourself 4 times what number is 0. The only thing times itself that's equal, or the only thing to multiply to get to 0 is 0. So if I did 4 times 0, I'd get 0. Another way to think about it is I divided both sides by 4, and 0 divided by 4 is in fact 0. And I was just double checking to see if it worked. If I plugged in 0 here, this would just be a 7, and that would just be a 3. 7 plus 3 is 10, plus 11 is 21, so 0 actually is the correct answer. Kind of strange. WT, let's do it. Holy moly, what am I going to do here? We're trying to figure out the whole length all the way across. So we're going to need to figure out, kind of like that very first one we did, or one of the first ones we did, where we had to figure out these 2 individual lengths. That's what we're going to do first. However, what we can do right away is that from W to U is x plus 21. Now, if I put a little question mark on top of this one, I could say that x plus 21 plus, sorry, x plus 21 plus, yeah, that's right, plus the question mark is equal to x plus 23. The reason why this is going to work out for us is only because of the fact that these both have just a little single x in it by itself. If you have that single x in it by itself, this is a plus sign, by the way. I really apologize for my handwriting there. That's a plus sign. So the x's will cancel. Like if I subtracted x on both sides here, like those x's are gone, and I end up getting 21 plus the question mark is 23. Don't think it takes that much effort to figure out that the question mark must in fact be a 2. There's my 2 up there. And again, that only worked out that way because these were exactly those x's by itself. There are always multiple ways to do these questions, and that's how I did this one. From here, 14 is from V all the way to T, which means, I'm going to go ahead and do this in a separate color for this next part. It must be the case that x plus 19 plus 2 is equal to 14, because we just figured out that that length there must be 2. There's our x plus 19. We're going to go ahead and do our little subtraction there. 14 minus 19 minus 2, that's going to give us negative 7. Again, use a calculator if you ever want to. There's no need to try to do these in your head like I'm doing. If you figured out that x is equal to negative 7, you're finally almost done. WT is the entire length, x plus 23. So WT is equal to negative 7 plus 23, which is in fact 16. Let's move on to the next question. So I'm going to make sure I divide this up. So this one, what's our plane of attack here? We're doing TV. So we're trying to figure out the TV. That's funny. So that's going to be 2x plus 7. That's that whole length. So we figure out what x is. We're done. To figure out what x is, well, we have this 31 here. That's the entire dang length. What else can we do? We can say, I need to pause for my own self here. We know that like UV here, we can figure out that UV is in fact equal to, UV has to be the 2x plus 7 minus that little tiny part right there, that's 2x minus 2. So we could say 2x plus 7 minus, I'm going to make sure I'm careful here with my parentheses, 2x minus 2. So if you notice, I just did my little subtraction there. We figured out that whole length. A little bit tougher to do for sure, but we end up figuring out that 2x minus 2x is nothing. 7 minus a negative. When you do your minus a negative, remember that you're distributing this negative sign to both of them. When you distribute that negative sign to both, it ends up becoming a positive 2. So 2 minus 2 is 0, and 7 plus 2 is in fact 9. So we have that UV there is 9, and then we're trying to find TV. Because we're trying to find TV, we still have not figured out what X is, so we do need to figure out what X is. How are we going to figure out what X is here? So we got that guy's 9. Well, because if I use the 2x, it's going to end up some canceling. I don't want to do that. What is our best way? Well, the whole thing is 31. We know the whole thing is 31. We know that UV is equal to 9, and we know that this part is 10x plus 2. So we're going to have 10x plus, no, 10 plus 2x. Richards. 10 plus 2x, and then we're going to add that 9 there. And that gives us the 31. We're now going to go ahead and subtract over, so 2x is equal to, and we're subtracting the 10 and the 9 from 31. 31 minus 10 is 21, minus 9 is 12. Divide both sides by 2, and you get 6. Last but not least, we need to figure out what TV is. TV is the whole length here, which is 2x plus 7. TV is equal to 2x plus 7. That is 12 plus 7, that's 19. Ooh, that was a tough one. That was the toughest one we've had so far. So it goes, little note to self to Mr. Richards. Make sure we note that that one's a tough one for class when we do it. All right. We are on to our last couple questions. If you'll notice, the questions get harder and harder as time goes on. I try to make it so there's not too many crazy difficult questions on there, but yeah, that's where we are. Find x if BD is equal to 3x minus 2, and they're all collinear. Position that order. I think we're going to need to draw a picture for this one. And then we have a lot of letters here. We have 4 letters. So we have A, B, C, D, A, B, C, D. You're told that the entire length here from side to side is 14. You're told from here to here is 7. And because that's 7 and the entire length is 14, that also means that right away, before we even finish setting the rest of this up, this one also has to be 7 because it is equal to 14 minus the 7. So that one's also 7. Anyways, we're told that BC is 1 plus x. And we're told that BD from here to here is 3x minus 2. All right, and what are we trying to find? Figure out what BD is. Well, luckily, we've already figured out that was 7. That helped us out right away. We noticed that we could just do that 1 plus x plus the 7 is 3x minus 2. Nice. So we have 1 plus x plus the 7 we just found is 3x minus 2. Let's do our switcheroo here. 3x minus the x is equal to 1 plus 2 plus 7. 10 is equal to 2x. Divide both sides by 2, and we end up with 5 is equal to x. And that's all it wanted us to find x. We're done. We're almost done here, guys. Only 3 more questions. So we have the letter A, the letter B, the letter C, the letter D. we're told right away this is 2x minus 7. That's easy. CD is x minus 3. And BC is 5. And the entire thing is 22. So actually, that's like the easiest one we've done, actually. There wasn't really a whole lot of thinking there, and that's okay. So we have 2x minus 7 plus 5 plus x minus 3 is equal to 22. Doing our little switcheroo, but we're going to add them at the same time. A 2x and an x added together is going to be a 3x. And now we're doing 22. We're going to have to add the 7 and the 3, so that's like adding 10. So 22 plus 3 is 32. Then subtract 5, you get 27. Divide both sides by 3, and you're done. Beautiful. Number 23. Find BC if... Oh, we have to do this whole thing. Same exact idea. I think these are going to be the toughest ones again. So we have A, B, C, D. AD, the entire thing is x plus 36. This guy here is 5. This guy here is x plus 20. And this guy here is x plus 21. This one will actually be difficult because we're just going to go ahead and say x plus 21 plus x plus 20 plus that 5 is equal to x plus 36. Like I was saying earlier, when you have exactly the same thing on both sides of the equation, you're always able to just cancel them. So this x and this x are just gone. So we can just copy that x down. Last but not least, we can go ahead and do a little bit of subtraction here. So a little bit of subtraction, we have the 36. We're going to subtract the 21, subtract the 20, subtract the 5. What's that going to be? It's like negative 10. You did 36. The way I did that, by the way, I did 21 and 20 is 41. 41 and 5 is 46. 36 minus 46, that's negative 10. But it wants us to find BC. That's negative 10 plus 20. That's positive 10. We're done. Here we go. One last one, and this one has all x's, a whole bunch of x's all over the place. Hopefully we do this one right on our first try. We've only had, what, 1 or 2 mistakes so far today? Doing pretty decent, to be honest. So BC is 2x plus 1, AB is 7, CD is 2x plus 1. The whole dang thing is x plus 9. All right, and we just add them all up because they equal x plus 9. So 7 plus 2x plus 1 plus, did I write 2x plus 1 twice? Well, I did because that's what the problem said. All right, equals x plus 9. It's switcheroo time here. 2x plus 2x minus x. So I copied, subtracted, equals, copy the 9, subtract, minus 7, minus 1, minus 1. 2 plus 2 minus 1 is 3. 9 minus 7 minus 1 is 0. So x is in fact equal to 0. Does that make sense here? 7 plus 1 is 9. It sure does. So CD must be 2 times 0 plus 1. You just get 1. Easy peasy. That's the whole thing. Have a wonderful rest of your day, guys, and peace out.